Good afternoon, students. Welcome to the 45th lecture of Fluid Mechanics subject. So, we are in the unit 3 of Fluid Mechanics. That is, we are dealing with laminar and turbulent flows. Now, the topic to be discussed is the pipes, the flow of fluid in a pipe which are connected in parallel connection. So, we have two types of connections, that is series connection and parallel connection. So we have already discussed about the series problems and equivalent pipe problems, and also we are discussing now the parallel pipes, the part 2 problems. Okay, yes, we'll go ahead. So as already mentioned, so the topics what we are discussed for this major losses and minor losses, right? Major losses and minor losses. So we have two different formulas, that is Darcy formula and Chassis formula. Darcy formula and Chassis formula. For the major losses and for the minor losses, we are having various other problems, that is at the contraction, that is at the expansion, that is at the entrance of the pipe, the exit of the pipe, and also the pipe fittings, various pipe fittings, and the bend of the pipe. So like this, we are having various parameters for this minor losses. Next, coming to the HGL and TGL, and also we have discussed about series pipes and parallel pipes. Now, in the last class already we have derived the formula for this parallel pipe connection. So we have Q1 and Q2. Okay, so we have done this parallel pipe connection. Okay, so based upon this parallel pipe connection, we have solved some problems. Okay, so these are the problems what we have solved in the last class. Okay, so these have completed easily. Okay, so here what is the simple thing? We have to see Q is equals to Q1 plus Q2, right? So this is also the earlier problem what we have solved by taking this pipe diameter. Now we are discussing the next problems under parallel pipe connections, right? So here a pipe of diameter 20 meters, a pipe of diameter 20 centimeters, diameter is 20 centimeters, and the length of the pipe is 2000 meters, connects two reservoirs, connecting two reservoirs A and B. So the figure is there. So see here. So this is a reservoir A. This is a reservoir B. So A and B reservoirs are connected by three pipes: Q, Q1, Q2, and Q3. So what is the question here? Connecting two reservoirs having a difference of water levels 20 meter. So the difference in the water level is 20 meter. So see here. The difference in the water level is 20 meters from here to here. So we have to check from here Ninchi the height of the reservoir A head level, the height of the reservoir B head level. E రెండిటి మధ్యలో distance is 20 meters. Okay, 20 meters. Now determine the discharge of the pipe. Determine that Q discharge through the pipe if an additional pipe of diameter 20 centimeter, if an additional pipe, of diameter 20 centimeter and length to 1200 meters is attached to the last 1200 meters length of the existing pipe. Already ఉన్న existing pipe low, right? So additional pipe of diameter 20 centimeters and the length of 1200 meters is attached to the last 1200 length of the existing pipe. Find the increase in the discharge and take F is equals to 0.05 for all the three pipes, neglecting the minor losses. So minor losses తీసేస్తే మనకి ఏముంటుంది, friction loss ఉంటుంది, that is HF. Okay, so what it is saying, so here it is saying that 1200 centimeters. So the 1200 centimeters and at the last end you are having the other 1200 centimeters. Okay, so total pipe from A to B is 2000. తర్వాత ఏం చెప్పాడు, the length is attached extra length 1200 దగ్గర నుంచి. సో 2000 minus 1200 ఎంత 800. సో 800 కనెక్షన్ దగ్గర నుంచి, సో the total pipe is 1200. So from here to here this is 800. So from here to here it is 800. Ikkada balance is 1200. The other pipe connection is 1200. So like this it is given. Now write the given data. What is the diameter of the pipe? The diameter of the pipe small d is equals to 20 centimeter, that is 0.2 meter. Then what is the length of the pipe? Capital L is equals to 2000 meters. L length is equals to, total length is equal to 2000 meters. Then the difference of the water levels. The difference of water levels H. What is the difference of water level H? 20 meters. Then the coefficient of friction F is equals to 0.015. 0.015. Okay. Now take the first case. So in any cases we are having two cases here. So the first case is this one, the second case is this one. Okay, now see the first case. When the single pipe connects the two reservoirs, ante A దగ్గర నుంచి B వరకు, the total single pipe connection length is 2000 meters. Okay, now see the head loss HF. HF is equals to 4 into F into L V square by D into 2G. Okay, therefore so మనకి V తెలియదు కాబట్టి, so V is equals to discharge into area, that is equal to V is equals to Q by pi by 4 D square. So అదే మనం ఇక్కడ రాసాం. So 4 into F into L into so on so. So finally H is equals to 32 F into L into Q square by pi square into G into D to the power of 5. Okay na? Now see, now substitute the values. What is the H value? 20 meters. What is the 32 into 0.015? 32 into 0.015. L is equals to 2000. L is equal to 2000. Q square we don't know. Pi square into 9.81 into 0.2 to the power of 5. So ఇవంతా substitute చేస్తే you are getting this value. Therefore what is the Q here? Q is equals to root of 20 by so on so. Therefore finally the discharge is equals to 0.0254 meter cube per second. Meter cube per second. Next, the second case. So that is for first case. Say the reservoir 1 to reservoir 2, the total length is given, it is done. Then what is the second case here? In this second case, so this first case is over. From here to here, that is the first case. Then what is the second case here? This case. Okay, now see the second case, two chances. Here in the second case, let Q1 is equal to discharge through the pipe CD. So discharge to the pipe C to D. Next from D to E, Qt is equals to discharge through the pipe DE. Q3 is equals to discharge through the pipe DF. Therefore you are having three types. One is C to D, D to E and D to F. So therefore you are having three types of discharges. Three types of discharges. Three types of discharges. Okay. So initially we took the case one, starting ikkada nunchi ikkada తీసేసుకున్నాము, we got the discharge Q. Overall discharge Q అనేసి మనకు వచ్చేసింది అనమాట. Okay, overall discharge Q. So in the second case we are having three discharges from here to here, here to here, again taking a loop and here to here. So taking those things into consideration now, so Q1 is equals to CD, Q2 discharge at DE, Q3 discharge of pipe DF. Now what is the length of the pipe CD? Length of the pipe CD is equals to 2000 minus 1200, that is L is equals to 800. So L 800 అనేది క్వశ్చన్ లో ఇవ్వలేదు, but we have to minus 8 by drawing the figure, by showing the figure. Next, the length of the pipe DE, the length of the pipe DE L2 is equals to 1200 meters as shown on the figure. Then what's the diameter is same, the diameter is same, therefore the velocity also will be same. Then what's the diameter length of the pipe DF? L3 is equals to 1200 meters, therefore D3 is equals to 0.02. Okay, 0.2 meters. Therefore since the diameters and the length of the pipe of DE and DF are equal, therefore Q2 is equals to Q3. And logically the Q2 will be equal to Q3. Therefore what is the general formula for this one? Q is equals to total Q1 plus Q2 plus Q3, but here Q1 is equals to Q2 plus Q3. So see here Q1 is equals to Q1 is equals to Q2 plus Q3. Okay, therefore, we know that Q2 is equal to Q3. Therefore, Q1 is equals to Q2 plus Q2 double times. Why? Because the diameters are same. Therefore, 2Q2. Q1 is equals to 2Q2. Therefore, Q2 is equals to Q1 by 2. Okay. After doing this one, so we have to go for the Bernoulli's equation at point A and point B, taking the flow through CDE, taking the flow through C and D and E. So we have what? The formula 20H is equals to 4F into L1 V1 square by D1 into G plus 4F L2 into D2 into 2G, where where V1 is equals to discharge by area, that's equal to 4 Q1 pi into zero point 0.4 into comma V2 is equals to discharge by area, that's equal to so and so, that is equal to the value this one. Now substituting this V values in this above equation, therefore 4 into 0.105 into 0.800 divided by 0.2 into 2 into 9.81 into V1 square plus 4 into this ఇదే రాసుకోండి దీన్ని చూసి ఇది వేయండి ఓకే 4 into 0.05 into 1200 divided by 0.2 into 2 into 9.81 into V2 value and this one Q2 Q1 into pi by 4 to the power of 2. So after solving this equation, finally we are getting this value. Okay. Therefore, Q1 is equals to 20. So 20 ఇక్కడ 20 already ఉంటుంది కదా ఇక్కడ 20 H. So Q1 is equals to H by 17041 square. Therefore, Q1 is equals to root of 20 by 17041, that is equals to Q is equals to 0.03. Therefore, what is the increase in the discharge? So general increase in the discharge is Q1 minus Q. So what is the question given? What is the discharge under? It's additional pipe. Find the increase in the discharge. So general discharge increase in the general discharge, what is the Q? Q is equals to 0.02. Then what is the actual discharge we got? Q1 is equals to 0.03. So therefore, minusing this 2, we are getting this is the increase in the discharge. Okay. So like this, you have to do the problem. But now you are getting the pipes in parallel connection. Understood the problem, right? So simply first write the given data, write the formulas. So you have to take the cases. You have to take first case, second case, like that in this parallel pipe problems. Why? Because so directly మీకు ఇక్కడ నుంచి ఇక్కడికి ఉందనుకోండి connection, that is series connection, so there is no need of doing that. So whenever you are having the problem given in a parallel type, so once you have drawn this one, first you have to make this arrangement. For this drawing of this also, first when you analyze the problem detailedly and you draw the problems correctly and mentioning the labels for that, for this also you'll get some 2 marks. So that given data, formula to find, and the problem, minimum you will get out of 15 marks, 2 plus 2 plus 2 plus 1. So easily you are getting 7 marks. Half marks you will get beyond your calculation and the answer. So like this, you have to do the problem in this series connection. Hope you understood the problem, right? Very simple concept. Okay. Next one. Next problem. Okay. Okay. Two pipes have a length L each. Two pipes having a length L each. One of them has a diameter D. One of them having a diameter D, and other is having a small d. So difference in the pipe. If the pipes are arranged in parallel, the loss of head when the total quantity of water Q flows from them is small h. But if the pipes are arranged in series and the same quantity of Q flows through them and the loss of head is capital H, if D is equals to D by 2, find the ratio of H to H, neglecting the secondary losses and assuming the pipe of the coefficient as a constant value. Got it? Now, so here you don't have any problematic type. So this is a derivative type. Then what is the total length of two pipes of length L each? So from the given question, write the length of the pipe 1. L1 is equals to L. L and the diameter is capital D. D1 is equal to capital D. Then for the pipe 2, L2 is equal to L and diameter D2 is equals to small d. Then what is the total discharge given? Total discharge is Q. Then what is said? What is the question? He said the head loss when the pipes are arranged in parallel is H. When the head loss, the pipes are arranged in series is capital H. Therefore, if D is equals to small d is equals to D by 2 and F is equal to constant, find find uh, find the ratio of H to H. Therefore, taking the two pipes cavity, take the first case when the pipes are in series, when the pipes are connected in parallel. So when the pipes are connected in parallel, Q total discharge is equals to Q1 plus Q2. Then what is the loss of head? Each pipe is equal to loss of head in each pipe is small h. Okay, small h. Therefore, consider a pipe AB. So considering a pipe, so this is a figure according to the question. So here the first water is going and again is making two connections. One is a this pipe, another one is a this pipe, and again is going in a series connection. So now taking the pipe A B, taking the pipe A B and AC. So we are having AB and AC pipes. Now taking the pipe AB, 4 into F into L1 V square by D1 into 2G is equals to head loss, where V1 is equals to Q by A, Q1 by A, that is already we know. That is equal to 4 Q1 by pi D square. Therefore, here what is given? D1 is equals to D. Okay, D1 is equals to D. Therefore, see here, the D1 value is equals to D. So substituting this D1 is equal to capital D in this formula, we will get 4 into F into L, 4 Q1 by pi D square to the power of square divided by D into 2G. That is equal to H or so and so. This is a keep it as 2. Okay. Now, what is the next pipe you are having? Your pipe next pipe is AC pipe. ఇందాక మనం తీసుకున్న పైపు AB. Now the next pipe is AC. Therefore, upon directly substitute చేశారు ఇక్కడ 32 by 4 into F Q2 square by pi square D to the power of 5 into D is equal to H. Then what is D2 is equals to small d. Therefore 32 F into L Q1 square. So why Q1 square here? Q1 is equals to Q2. Okay na? Therefore 32 F into L Q1 square divided by pi by 4 d to the power of 5 into G. So ఈ వాల్యూ ఇక్కడ తీసుకున్నాడు. సో హియర్ this is equals to this, total is equal to h కాబట్టి, సో టేకింగ్ దిస్ ఈక్వల్, దిస్ వన్ అండ్ దిస్ వన్, ఈ రెండు ఈక్వల్ గా తీసుకున్నాడు కాబట్టి టేకింగ్ దిస్ టు ఈక్వల్. సో ఏం జరిగింది? క్రాసింగ్ జరిగింది. సో 32 ఇవన్నీ క్రాస్ అయిన తర్వాత ఫైనల్ గా ఏం మిగిలింది? Q1 square by D5 is equals to Q2 square by small d5, or Q1 by Q2 to the power of square is equals to D to the power of 5 by small d5. That is equals to D is equals to what is capital capital D is equals to 2D. Constant చెప్పాడు కదా, capital D is equals to 2D. Therefore apply here 2D to the power of 5 by D5. Therefore 2 to the power of 5 ఇది తీసుకురండి. సో ఇక్కడ మీరు D5 క్యాన్సిల్ చేస్తే you are having generally 2 to the power of 5 is equals to 32. Now Q1 by Q2 is equals to root 32. That is equals to 5.67, or Q1 is equals to 5.657 into Q2. Okay. Got it? So ఇక్కడ large D, big D is capital D is equal to 2D కాబట్టి, సో D ని 2D to the power of 5 వేసాడు. సో D5 క్యాన్సిల్ చేసుకుంటే, right, you are having 2 to the power of 5, that is 32. Q1 by Q2 is equals to so and so, Q1 is equal to 5.6 Q2. Now substituting values of Q1 in original equation. ఏదే original equation substitution 1? This equation. Q is equals to Q1 plus Q2. దీనిలో substitute చేస్తే we get Q is equals to 5.657 Q2 plus Q2, that is equal to 6.657 Q2. Therefore, Q2 is equals to Q by so and so, that is 0.1 Q. So make it as other point. Therefore, from the equation 1, Q1 is equals to Q1 ఇటు తీసుకొచ్చారనుకోండి ఈక్వేషన్ 1 లో ఈ Q అటు వెళ్ళింది. సో Q minus Q2. Therefore, Q that is equals to Q minus Q2 value ఎంత 0.15 Q. Therefore, Q minus 0.15 Q, that is equal to 0.85 Q. Q1 is equals to 0.85 Q. That is a equation for this pipe connection. First case. When coming to the second case ఏంటి question లో when the pipes are connected in series, therefore the total loss is equals to sum of the head loss in the pipe connections of the two pipes, that therefore the total loss is equals to sum of the head loss. Therefore H is equals to total loss, H is equal to sum 4F into L into V1 square by D1 into 2G plus 4F into L into V square by T2 into 2G. Okay na? Now what is the next thing? We know the V1 is equals to Q by A, V2 is equals to Q by A. Substituting these values here, so V1 value, V2 value ఇక్కడ మీరు substitute చేస్తే the calculations will be totally different. So what's happening here? The Q V1, Q2 Q. So exiting outside, therefore H value, H is equals to దీనిలో substitute చేయండి. So after keep on substituting this one, we are getting simplifying, we are getting H is equal to so and so. Now from the equation 2 substitute here. Equation 2, what is equation 2 here? So equation 2 low. From the equation 2, this one. So and from the equation 3, this one. Right? So this equation 2, H by Q1 square. Equation 2, H by Q2 square. Substituting these values in Q6, substituting this value in the 6. Therefore, what you are getting, H is equals to this one and the Q2 into H by Q1 to the power of square plus Q2 into H by Q2 to the power of square is equals to Q2 by Q1, Q2 square by Q1 square into H plus Q2 square into H. That is equal to H of Q2 by Q1 square plus Q2 by Q2 square. Therefore EH, this H is coming downside, this H is coming downside. H by H is equals to Q square by Q1 square plus Q2 square by Q2 square. Got it? Now from the equations 5 and 6, from the equations 4 and 5, from these equations 4 and 5, what is the value of Q1? Q1 value is 0.85 and Q2 value is equals to 0.15 Q. Now substituting in this equation H by H, there substitute cheste Q2 by Q1 value వేయండి plus Q2 by Q2 value వేయండి. So finally you are getting 1 by 0.885 square plus 1 by 0.15 square, that is equals to 1.384 plus 44.44, therefore 45.825. Therefore the ratio of capital H by small h yes. So after adding this one, you are getting the value 45.828. That is equal to ratio of capital H by small h. So what is the question given? Find the ratio of capital H to small h. Find the ratio of series to parallel. So that's why the value is series to parallel, H by H is equal to 45.828. So this is a other case of doing the parallel type of problems. Okay, right? Hope you understood this problem. So we'll go with the next problem. Okay, this. We'll discuss the next third problem. So here in the problem 11.39, so we are having other study of this parallel flow connection. Now the pipe of diameter is 0.4 meter. The length of the 0.4 meter diameter pipe is 2000 meter, is connected to a reservoir at one end. So for one end of the reservoir, you are having 2000 meters length of a pipe with 0.4 diameter. The other end of the pipe is connected to a junction from which two pipes of length 1000 and 300 diameter running in parallel. So ఇక్కడ ఏం జరిగింది, for example this is a reservoir. ఈ reservoir కి you are having 2000 meter pipe connected. From this pipe junction you are having two lengths of 1000 meters and diameter 300. So two pipes connected like this. Two pipes are connected like this. Okay. Now see here. See. So this is a reservoir. The pipe you are having 2000 and it is making a parallel connection. And these are summing up, adding at other reservoir which is making a different diameter. Now see the junction in the figure basis 1000 meters and 300 running parallel. These parallel pipes are connected to other reservoir. So what's the question here? These parallel pipe connections are connected to the other reservoir which is having a level of water 10 meters below the water level of the above reservoir. So ilanti type of problems you have to study the problem minimum 3 or 4 times and you have to understand the content in Telugu. So ఇక్కడ ఏం చెప్పాడు, these parallel pipes are connected to other reservoir. ఈ రెండు పైప్ కనెక్షన్స్ వచ్చేసి కనెక్టెడ్ టు అదర్ రిజర్వాయర్. బట్ ఇదేంటి, ఇది గ్రౌండ్ లెవెల్ అనుకుందాం. సో వాట్ ఈస్ సేయింగ్ విచ్ ఈస్ హ్యావింగ్ ఎ లెవెల్ ఆఫ్ వాటర్ 10 meters బిలో ద వాటర్ లెవెల్ ఆఫ్ ద అబోవ్ రిజర్వాయర్. సో అప్పుడు మీకు సేమ్ రిజర్వాయర్ ఇక్కడ వస్తుందా, రాదు. ఏం చెప్పాడు, 10 meters బిలో అన్నాడు. బట్ వాట్ 10 meters వాటర్ లెవెల్ బిలో అంటే, ఫర్ ఎగ్జాంపుల్ ఇఫ్ యూ టేక్ ద వాటర్ లెవెల్ ఇస్ లైక్ దిస్. సో ఇఫ్ యూ టేక్ ద వాటర్ లెవెల్, ఈ వాటర్ లెవెల్ నుంచి 10 meters కిందకి means, so అప్పుడు మీకు స్ట్రైట్ గా పెడితే కనెక్షన్ రాదు. దెన్ వాట్ యూ హ్యావ్ టు డూ, యూ హ్యావ్ టు డ్రా ఎ రిజర్వాయర్. స్ట్రైట్ గా పెట్టారనుకోండి, సో స్ట్రైట్ గా పైప్ వస్తుంది, స్ట్రైట్ గా రిజర్వాయర్ వస్తుంది. కాబట్టి మేక్ ఎ డౌన్ కనెక్షన్, మేక్ ఎ క్రాస్ కనెక్షన్, స్లాంట్ కనెక్షన్. సో మీకు కనెక్షన్ ఇలా ఇవ్వండి కిందకి. దెన్ సో దిస్ ఈస్ ది సెకండ్ రిజర్వాయర్ కనెక్టెడ్ టు ద సెకండ్ రిజర్వాయర్. దెన్ వాట్ ఇస్ ద హైట్ ఆఫ్ ద వాటర్, ఇది ఒక హైట్ ఆఫ్ ద వాటర్ అనుకుంటే, ఇది ఒక హైట్ ఆఫ్ ద వాటర్ అనుకుంటే, దెన్ ఈ హైట్ నుంచి ఈ హైట్ కి ద టోటల్ ద డిస్టెన్స్ ఇస్ 10. సో ఇది దాని మీనింగ్. ఇది దట్ ఇస్ ద మీనింగ్. నౌ సీ ద ఫిగర్ హియర్, అంతే కదా. సో దిస్ ఈస్ వన్ రిజర్వాయర్, దిస్ ఈస్ వన్ రిజర్వాయర్. సో స్లాంట్ గా పైప్ కనెక్షన్ చేసి ఇక్కడి నుంచి జంక్షన్ తీసుకొని 1000 లెంత్, సేమ్ 1000 లెంత్ తీసుకొని మళ్ళీ తీసుకెళ్ళి జాయిన్ చేశాడు ఒక చోట. Right, then he's saying that the water levels is 10 meters apart. So 10 meters ఉందన్నమాట. సో దట్స్ వై దీన్ని స్ట్రైట్ గా పెట్టారనుకోండి, మనకి రిజర్వాయర్ కూడా సేమ్ ప్లాట్ఫామ్ మీద వస్తుంది. దట్స్ వై క్రాస్ గా పెట్టి కింద చూపించాడు, కింద అదర్ బేస్ మీద. నా ఈ వాటర్ లెవెల్లో ఈ వాటర్ లెవెల్ కి డిఫరెన్స్ తీసుకుంటే దిస్ ఇస్ అ 10 meter. దట్ ఈస్ అ గివెన్ ఇన్ ద క్వశ్చన్. నౌ determine the total discharge if Q is equals to 0.015. So neglecting the minor losses. So na minor losses ఏంటి మనకి, కాంట్రాక్షన్, ఎక్స్పాన్షన్, ఎంట్రన్స్ ఇవన్నీ తీసేస్తే ఓన్లీ మనకి ఫ్రిక్షన్ లాస్ కనుక్కోవాలి. సో మేజర్ లాసెస్ కనుక్కోవాలన్నమాట. అదే మైనర్ లాసెస్ అనుకోండి, మీకు మేజర్ లాసెస్ ప్లస్ మైనర్ లాసెస్, మీకు యువర్ ప్రాబ్లమ్ విల్ బి 3 or 4 pages. సో దట్స్ వై నెగ్లెక్టింగ్ ద మైనర్ లాస్ అన్నాడు. సో మైనర్ లాస్ అంటే ఫిగర్లో ఎక్కడ వస్తుంది. సో ఇక్కడ ఏం జరిగింది, ఇక్కడ ఎంట్రన్స్ ఆఫ్ ద పైప్ ఇక్కడ ఒకటి జరిగింది. సో ద పైపు కాన్స్టెంట్ గా వెళ్ళింది. ఇక్కడికి వెళ్ళిన తర్వాత ఏం జరిగింది, ఇక్కడ 0.4 meter డయామీటర్ పైప్ ఉంటే ఇక్కడ ఏం జరిగింది, 0.3 ఉంది. సో ఇక్కడ ఈ టైంలో ద పైప్ హ్యాస్ బీన్ ఎక్స్పాండెడ్, ద పైప్ హ్యాస్ బీన్, ద వాటర్, ద ఫ్లో ఈస్ distributed. Again ikkadiki em jarigindadi, again it is going into the deeper section. So you have to take the minor losses at this point, minor loss at this point, expansion, again you have to take the the losses here. So additionally you are having other problems. So that is not for 15 marks, it may be of more than 15 marks. So that's why along type of questions generally they won't give. So you have to do only దిస్ వన్. ఇక్కడ నుంచి ఇక్కడికి ఫ్రిక్షన్ లాస్, ఇక్కడ నుంచి ఇక్కడికి ఫ్రిక్షన్ లాస్, ఇక్కడ నుంచి ఇక్కడికి ఫ్రిక్షన్ లాస్. దట్స్ వై వీఆర్ కీపింగ్ పాయింట్ ఏ, పాయింట్ బి, పాయింట్ సి, పాయింట్ డి, తర్వాత రిజర్వాయర్ ఈ, రిజర్వాయర్ ఎఫ్. సో యూ కెన్ టేక్ ఎనీ నెంబర్స్. దీన్ని ఏ పెట్టుకోవచ్చు, ఈ పెట్టుకోవచ్చు, సి పెట్టుకోవచ్చు, డి, ఈ పెట్టుకోవచ్చు, ఎఫ్ పెట్టుకోవచ్చు. లేదంటే ఇక్కడ పి పెట్టుకోవచ్చు, క్యూ పెట్టుకోవచ్చు. దీన్ని నార్మల్గా ఏ పైప్స్ కాబట్టి పైప్స్ వరకు ఒక పేరు ఇచ్చాము. ట్యాంక్లకి వీ కెన్ కీప్ అదర్ నేమ్స్ ఆల్సో. ఓకేనా? నౌ what is the coefficient of friction? The coefficient of friction is 0.015 for both cases. Now write the given diameter. So ilanti type of problems ki given data rasi what em adugutunnaru to find rasi figure rasi వదిలేసారు అనుకోండి, మినిమం విల్ గెట్ 4 మార్క్స్. చాలు కదా పాస్ అవ్వడానికి. అడిషన్, జస్ట్ అడిషన్ అంతే. మినిమం 4 మార్క్స్ అట్లా చేసుకుంటూ వెళ్ళారనుకోండి ప్రతి ఒక్క ప్రాబ్లం. గివెన్ డేటా రైట్, కరెక్ట్ గివెన్ డేటా, ఫిగర్ ఉంటే ఫిగర్ వేయండి, టు ఫైండ్ రాయండి, ఫార్ములా తెలిస్తే రాయండి, చేసినంతకు చేసి వదిలేసేయండి. సో దట్ యూ విల్ స్కోర్ మినిమం మార్క్స్, సో దట్ ఇట్ విల్ బి వెరీ యూస్ఫుల్ ఫర్ యువర్ పాసింగ్ ఆఫ్ ద టోటల్ subject. Now what is the diameter of the pipe? So every class I am telling like this only. Why? Because you have to keep in mind. So కొంతమంది ఏం చేస్తారు, why? Because we have seen many papers during paper evaluation correction చేసేటప్పుడు minimum, if the person is having some minimum talent, minimum logic, as it is question paper రాసినా కూడా no use, 0 marks వస్తాయి. But instead of writing as it is question mark, those who are having fear of doing the problems, that's why I said practice theoretical concept. Theoretical concept practice చేస్తే out of 100 marks కి minimum you will get 30 marks. Minimum కరెక్ట్గా రాస్తే. రాయలేదు అనుకోండి మినిమం you will get 18 marks or 15 marks. ఓకే, టేక్ 15 marks. పాస్ అవడానికి ఇంకెంత ఉంది? 10 marks, అంటే 24, అంటే 9 marks రావాలి. సరే 10 marks వేసుకుందాం. సో ఫర్ ఎవ్రీ ప్రాబ్లం వాట్ యువర్ ఇది చాయిస్తో మీరు కరెక్ట్గా రాస్తే, ఫర్ ఎవ్రీ ప్రాబ్లం గివెన్ డేటా టు ఫైండ్ ఫిగర్ ఫార్ములా, గివెన్ డేటా ఫైండ్ ఫిగర్ ఫార్ములా, ప్రతి ప్రాబ్లంకి వేసుకుంటూ పోతే ప్రతి ప్రాబ్లంకి, ఫర్ ఎగ్జాంపుల్ పార్ట్ బిలో యూర్ హ్యావింగ్ 1 2 3 5 ఉన్నాయి అనుకోండి. 5 క్వశ్చన్స్కి మినిమం డేటా రాసుకుంటే 3 మార్క్స్. 5 3s are 15. సో థియరీ 15, ప్రాబ్లమ్స్ 15, టోటల్ 30 మార్క్స్. సో మీరు 6 మార్క్స్ అడిషనల్గా యు ఆర్ గెయినింగ్. సో వితౌట్ సాల్వింగ్ వన్ ప్రాబ్లమ్ ఆల్సో యూ కెన్ పాస్ ద ఎగ్జామ్ బై హ్యావింగ్ దిస్ లాజిక్ థింగ్స్ ఇన్ ద మైండ్. ఇవి నేను ఎవరికి చెప్తున్నాను? నాట్ ఫర్ ఆల్ ద స్టూడెంట్స్, దోస్ హూ ఆర్ వెరీ బ్యాడ్, ప్రాబ్లమ్స్ అంటే భయం అని అనిపించిన వాళ్ళకి మాత్రం చెప్తున్నాను. అండ్ ఆల్సో ఇన్ హరీ టు లెర్న్ ద సబ్జెక్ట్, ముందు రోజు కూర్చొని చదువుకుంటారు అలాంటి వాళ్ళు. బట్ దోస్ హూ వాంట్ టు స్కోర్ గుడ్ మార్క్స్, వాట్ ఐఎమ్ సేయింగ్ ఇస్ టోటలీ రాంగ్. టోటలీ రాంగ్ కాన్సెప్ట్ నేను చెప్తున్నాను. ఏది? దోస్ హూ వాంట్ టు గెట్ స్కోర్ గుడ్ మార్క్స్ ఇన్ దిస్ టైప్ ఆఫ్ ప్రాబ్లమాటిక్ సబ్జెక్ట్. సో కీప్ ఆన్ ప్రాక్టీసింగ్. వై? బికాస్ తర్వాత ఎంటెక్ ఎంట్రన్స్, అదర్ గవర్నమెంట్ ఎగ్జామ్స్, అదర్ కాంపిటేటివ్ ఎగ్జామ్స్కి టెక్నికల్ పేపర్ ఇచ్చినప్పుడు దిస్ విల్ బి వెరీ యూస్ఫుల్ ఫర్ యూ. ఓకే, నేను మీకు అన్ని విధాలుగా చెప్తాను. మీరు డిపెండ్స్ అపాన్ యువర్ ఐ హావెంట్ సీన్ యువర్ ఫేస్, యూ డోంట్ నో మై ఫేస్, రైట్? Your seniors, second years, third years, fourth years, they know me, but you don't know me, though I am from mechanical department. But you have seen me, I don't know. But మీకు ఎందుకు చెప్తున్నానంటే, as a faculty I have to tell the students, to teach the students how to promote in a positive way, not in a negative way. Questions ఇచ్చి ఆన్సర్స్ చదువుకోండి. దట్ ఈస్ ఓన్లీ ఫర్ టెంపరరీ మార్క్స్. మిడ్ మార్క్స్ వరకు వస్తుంది, ఏం చేసుకుంటారు? నెక్స్ట్. Okay, what is the diameter of the pipe? Small d is equals to 0.4. What is the length of the pipe? 2000 meters. What is the other end of the pipe is connected to the junction of the two pipes of length 1000 meters and diameter. Okay, the other length diameters are d1 is equal to d2, that is equal to 0.3 meter. What is the other length of the pipe? L1 is equal to L2, that is equal to 1000 meter. ఇంతవరకు given data. Then what is the head level? Head level h is equals to 10 meters, f is equal to 0.5. ఇది given data, ఇది given data. Okay na? Now by seeing the diagram కూడా వేసేసారు కాబట్టి, by seeing the diagram, applying the Bernoulli's equation, the point T, E and F, taking the flow of ABC. So total flow తీసుకోండి. ఫస్ట్ కేస్ 1లో A, B, C టోటల్ తీసుకోండి. Now taking the case ABC, therefore what is the head? 10 meters is equals to 10 meters is equal to friction losses. This plus this. Therefore 4FLV square by D into 2G plus 4FL1 into V1 square by D1 into 2G. So ఎందుకు ఇక్కడ why because ఇది L ఉంది, A నుంచి B ఇదంతా ఒకటి తీసుకున్నాడు, ఇక్కడ నుంచి ఇక్కడికి ఒకటే తీసుకున్నాడు, ఎందుకంటే దీని డైమెన్షన్స్ సేమ్ ఉన్నాయి. అదే డిఫరెంట్ ఉందనుకోండి వేరేగా తీసుకోవాలి. సో హియర్ టేకింగ్ ద సేమ్, దేర్ ఫోర్ A to B అండ్ B to C. A to B వచ్చేసి లెంత్ 2000, B to C వచ్చేసి లెంత్ 1000. దేర్ ఫోర్ ABC, therefore 10 is equals to 4 into F into L into V square by D into 2G plus 4F into L1 into V1 square by D1 into 2G. Okay na? Now substitute here, keeping the values there. 4 into F into 2000 into V square by 0.4 into 2 into 9 into 8, 9.81 plus 4 into F value, L value, V1 square by 0.3, 2 into 9.8. So ఇవంతా సింప్లిఫై చేస్తే therefore we are getting 15.29 V square plus 10.19 V1 square. Okay, so 10 is equals to the total. Okay na? Now from the continuity equation, A1 V1 is equal to A2 V2 or discharge through AB. So discharge through AB నుంచి జరిగింది కాబట్టి AB is equals to BC plus CD. That is a continuity equation. So from the figure you can say the continuity equation AB is equals to BC plus BD. Now అదే ఫార్ములాగా you have to start making. Therefore discharge అన్నాడు కాబట్టి discharge Q, here also discharge Q, here also discharge Q. 3 discharges. Q is equals to Q1 plus Q2 అనైనా పెట్టుకోవచ్చు మీరు. Q is equals to Q1 plus Q2. Therefore ప్రతిదానికి discharge is equals to what? Velocity by area. అంతే కదా? Therefore velocity by area. So pi by 4 discharge is equal to velocity into area. Therefore V into pi by 4 d square. The time is not. Okay, only one Riyadh Sheikh. I think I have a class. Okay, 2:15 I have the other class for your seniors. So we'll stop the session here. So I think 1:20. Now the time is 2 o'clock. So I think 40 minutes అయిపోయింది అనుకుంటా. Okay, we'll discuss the class 120. Yes, 122. Okay, so we'll stop the class here. So I have the other class. We'll continue the class in the next session. Okay. So ఇంకా 2. Okay, ఇంకొక two classes ఉన్నాయి. So other concept we will discuss tomorrow. Okay, so thanks for listening to the class. Once this video is uploaded in the YouTube channel, I will forward this link to the WhatsApp group. Later you can see the video properly and forward this link to the other students, those who are not coming regularly and irregular to the class. So thanks for watching the video. Have a nice day. See you.